Hello, everyone, and welcome to the latest edition of Connected Data London's online meetup. Today, we have a theme to our meetup, which is enterprise knowledge graphs and how they can be used towards a knowledge-based economy. We have 3 talks lined up for you, and actually we're already kind of late for the first one, so I'll try to keep my intro as short as possible and just give the floor to Tony Seale, our first guest. Tony, the floor is yours. Actually, one last thing before I give you the floor. So big thanks to our sponsors today, Enterprise Web and France, who's also presenting next. Big thanks. Tony, floor is yours.
Okay. Hi, guys. Presuming everyone can see my screen, let me know if there's a problem. So the first part of my message really is very simple, and that is that there is an AI tsunami coming, but most people don't realize it yet. And enterprises are going to have to perform a 180 in the way they think about their data if they're going to survive that AI tsunami. And small tweaks and changes aren't going to cut it. We're talking about an existential shift in mindset here. And this starts with accepting that the way that large enterprises run their data at the moment is fundamentally broken, in my opinion. How come that your smartphone can recognize your face and understand your speech, but your IT department takes over 2 months to add a couple of fields to your report? And I think the first thing to realize here is that AI is built upon top of a data layer. And within the modern enterprise, outside of the tech giants like Google and Facebook, who've got this one sorted, outside of that, the data layer is broken within the large enterprises. In fact, it's non-existent. In a large enterprise, they'll have literally thousands of separately siloed pieces of data with systems connected together in a spaghetti of different technology. There's little standardization around security access, models, and there's a lack of a data culture which exists within the tech giants. Now, in many ways, this is not a new observation because what we're talking about here is the data integration problem. And the classic solution to the data integration problem is to build yourself a data mart or a data warehouse, which is just a big database where you grab all of your data and perform what's called an ETL process to basically merge the data all into one place. But the data warehouse has several problems. First of all, you've got to define the schema up front, which is not very agile. And then as the business changes, which they continually do change, the data warehouses really struggle to keep up with that. But perhaps more fundamentally, and this is where like the change of mindset that I'm proposing comes in, is that in order to survive the AI wave, then enterprises are going to have to kind of change their thinking and got to start thinking about connecting the total sum of the data assets within their company. And even with a really good data warehouse solution, you're not really talking about connecting more than, like, say, 1% or even less than that, really, of the total data assets of the company. And where I see the future going, that's just not going to cut it. So then we've got the newer kid on the block, which is Hadoop and various kind of big table technologies. And this is a step forward. All of these things are important step forwards, and I wouldn't want to denigrate any of the amazing effort that's gone on the road to progressing towards data integration. But I think it's fair to say that the sort of promise of crystal clear waters of data lakes haven't really materialized for the enterprises. They've blindly followed the tech giants into implementing this technology, and in most cases, they've ended up with a kind of data swamp, which kind of sits there, not really doing very much. And that's because although that they've grabbed a load of data, they haven't really tackled the hard part of the problem, which is conforming to schemas, to linking and connecting your data, to cleaning it up and extracting out the knowledge. And then also I've got news, which maybe is not news to many of the people on this presentation, but for some people will be, that the cool kids have moved on, and in fact they moved on quite a long time ago. And they've started, so Google and Facebook have started building knowledge graphs over the top of their data structures they've got. And the knowledge graphs provide schema and meaning to the data. Now, I think what we're going to see as knowledge graphs move up the hype cycle, and someone told me the other day that it's already kind of into the trough of disappointment already, that that enterprises will increasingly look to adopt an enterprise knowledge graph. But I've got a clear message here that I'd like to convey, which is that I don't think enterprises should just repeat the mistakes of the past and blindly copy what Google and Facebook are doing here. What do I mean by that? Well, you know, the knowledge graph is a genuine innovation. So for the first time, data relationships are able to be made first-class citizens, and that's really, really important. But the situation for the enterprise is different from the internet giants. There's the diversity of the data, and then just a kind of lack of data culture, which is deep-seated in the internet giants, but is not there yet within the enterprise, and that needs to be tackled. And in this sense, I think what we need to do is we need to combine the powerful technology of enterprise knowledge graphs with another topic which is emerging up through the hype cycle, which is decentralization. And it's actually through the combination of these two things that, and creating a sort of distributed enterprise knowledge graph, that we can potentially unlock this revolution. So let's turn to the graph part of this then. So most of you will know what graphs are, but I'd just like to spend a little bit of time on those to run through them and explain what's so great about them. And the first thing that I think is great about them is their very intuitive nature. So a graph is made of nodes, which we can see as these circles here, and these nodes are connected by what are called edges. And in terms of how you might kind of draw out your own knowledge about something, then this structure, this graph structure, is probably very intuitive to you, and it's maybe something you'd even kind of like doodle on a piece of paper. But okay, so that's graphs, but what is so great about them in this context? Well, the first thing I think is that they can capture the fundamentally messy nature of data, but they still retain enough structure for computers to sort of reason over them. And I've started calling it a kind of structured scruffiness. So let's turn to the main data structures, the sort of non-graph data structures that we're all familiar with today. And these are tables like Excel and relational databases, and trees. So the tree within your file system, or if you're technical, XML documents or JSON documents are an example of tree-like structures. And the flexible nature of graphs mean that they can model both tree-like data and tabular data with ease. And they can also contain even more complicated things like cycles. And this flexible nature means that they can even be used, and are used sort of out on the web, to provide islands of sort of certainty and structure within more complicated data structures like text and images. So in this sense, the graph doesn't so much replace these other data structures as provide a universal way of representing them and connecting them together, which I guess is why it's particularly right for this data integration problem. And that kind of goes to what is really the next great thing about graphs, and that is that graphs make relationships first-class citizens. They're just as important as the nodes themselves. And I would suggest that the more time that you spend thinking about data, the more that you'll realize that, in fact, data is all about the relationships, that facts don't exist in isolation, but rather they are positioned within the context of everything else. So maybe spend a moment after this contemplating that, and And I guess the ask here is to stop thinking about data in terms of separated business-aligned systems and instead concentrate on the relationships between them. Start thinking about your data as a kind of connected whole. Now, some people will say, well, I could do all of this within a different data structure. I could do this within a relational database or a graph store or a document store or whatever the particular favorite one is. And whilst this is true, I think it misses the point. Because graphs are made for this job, they make it really simple. And all you have to do is to break your data down into these like 3-part statements. So Ben is a person, Bob is a person, Ben's son is Bob, Bob lives in the UK. You can just keep on adding these little triples ad infinitum, and that's it. You atomize your data into these 3-part statements, and then as if by magic, out the other side pops this huge graph. It's not rocket science, and there's some misconceptions about that. Really, I think it's actually really rather simple, and anybody can do this. And that's why I think that graphs are one of the main keys for connecting enterprises' data together into a unified layer, and what I think is so great about them. So now I want to turn to the second key, so the concept of decentralization. So this concept is a bit harder to get your head around. It's even got a complicated name of decentralization. So let's try and break that down a little bit. Broadly speaking, and I'm sorry if I get a little bit philosophical here, but I will return back to data. But broadly speaking, I think we can break any complicated system, any complex system, down in 3 different ways. Firstly, we've got disordered systems. So that's a system with no rules or laws. We can think of this as the wild, wild west, where you can do whatever you like. Then secondly, we have highly centralized command and control systems where instructions are issued from the center down to the mass. And you can think of like the former USSR here, or like in a more scary scenario, like Skynet from the Terminator movie. And then finally, we have decentralized systems where we have a universally agreed upon set of standards that everyone follows. And then things are organized amongst nodes themselves, where they compete and collaborate with each other within this kind of common framework. And to sort of elicit the difference between the centralized model and the decentralized model, I like to tell a story, which is that apparently an official traveled from the former USSR to learn about the free market in London. Because despite years of hard work by a really intelligent team, the talented experts had failed to minimize the bread queues, and the Russian people were having to queue a long time for bread. Anyway, whilst traveling around London, looking at the London Stock Exchange, etc., and these various instruments of the free market economy, he eventually said, look, what I really want is for you to introduce me to the guy who's in charge of bread supply, because we've been working on this problem for absolutely ages, and I'm desperate to meet him and learn his great secret. Take me to him right now. And of course, within London, there was no one in charge of bread supply. And let's think about that for a second. So within the regulated market, the companies collaborated and competed with each other, and a highly optimized bread supply chain simply arose. And that's a really important point there. The complexity was just too great for these guys to hold in their heads. And in the decentralized system, responsibility was instead pushed down into the individual companies, and then an optimized bread supply chain simply arises out of thin air. That is the power of decentralization. So we can turn back to data now. And in most large enterprises, I think it's fair to say that they operate in some kind of the wild, wild west mode, where applications exchange data in a hodgepodge of different formats. And from a high level perspective, or even the low level perspective as a developer, to be honest with you, the the whole thing is a complete nightmare of different technologies and just basically a disorganized mess. To see this, I don't know how many of you are technical, but if you've ever seen like a kind of information flow of your company or just one department within your company, you'll know exactly what I'm talking about. So let's turn to the centralized model then. So the one that we kind of looked at in the initial couple of slides, and then to be honest, like the centralized model of organization in general, I sort of find something slightly creepy about that. But when we turn to looking at the central model for data integration, then scary efficiency really is the very last of our concerns. And my message here is it doesn't seem to matter what you put in the center here, be it a data warehouse or a data lake, or perhaps controversially, an enterprise knowledge graph. It's the centralized system just can't seem to connect more than a very small percentage of the overall company's data. And if you think about it, then it kind of makes logical sense, because these guys are like the USSR guys trying to plan the bread supply for the whole country. There's just no way that this central store can pull and organize all the data from thousands upon thousands, like literally somewhere between 50 to 70,000 different separate systems. There's just no way that the centralized system can contain all that complexity within itself, when each one often is quite highly complex in its own right. Anyway, here's the bottom line. After 20 years of dedicated, or more really, effort, the centralized approach just hasn't been able to link more than a small percentage of the overall company's data. Meanwhile, the AI revolution is unfolding around us and the clock's ticking. So let's think about a pivot here. Let's apply the decentralized model to data integration. In a decentralized data mesh, applications publish and consume data in a standard structure. So data stays where it is, but then it's exposed in this standardized layer. It's published rather than pulled, and individual applications are responsible for linking to each other. In this way, responsibility for the data integration is pushed down into the individual applications, who, after all, let's face it, are the experts in their own data and already know how they connect to each other in the spaghetti ball. So here I like to ask a question. You know, could this model do better than the 1% of connection? Could it come close to connecting all of a company's data together? And then I think, well, imagine that the CEO of a large enterprise said, within the next 6 months, I want every single one of these applications to publish their data according to this standard form. And then where they connect to each other, I want you to form links between each other. Go off and do it, each one of you. It's my #1 priority, make it happen. Within 6 months, could the resulting effort bring all of the data into a unified whole? Well, I don't know about 6 months, but in a way, I think it sort of could. It would be rough and messy at first. But if you set up what I'm calling like the right internal data market, then with a bit of luck and skill, hopefully the motor of decentralization should fire up, just like it did with the bread supply chain, and a clean and connected data layer would arise. So I'll leave you to think about that one. Okay, so having looked at decentralization, we can now turn back to the more intuitive concept of graphs, because, of course, this standard structure that we're going to ask each of the applications to publish in is the very same one that we talked about before, these simple 3-part statements. So each one of these applications publishing up the 3-part statements, and they're therefore making available just their part of the graph. And then where a data item from one of these applications links to the data in another one of the applications, then the applications create links between each other, and therefore out emerge decentralized graph. Okay, so we've kind of like talked in the hypotheticals, but down to like a more realistic level, like how this all sounds very nice, but what would it actually look like to implement something like this? And I can't tell you all of that over this talk now, but let me give you an intuition, because think about the web. It's the most successful integration project in human history, I would claim. It can sort of connected information. You've got products on there, financial instruments, you know, you've got facts, you've got photos, you've got music, people have posted up masterpieces. It's almost like the near sum of human knowledge. It's spread out across the entire planet, accessible through a browser window. And in short, I believe that it is a proven model for large-scale, complex information integration. So, from a technical perspective, we can view the web as a decentralized graph of connected documents. And as I've hopefully laid out, the has the potential to revolutionize data integration. So this is the cool thing here, I think, that the web gives us everything to create. All of these building blocks are there already to create this decentralized knowledge graph. Put more simply, the tools of the web to connect all of the near sum of the data within an enterprise together, so that just like with a web browser through a single lens. Let's drill into the so on the web technology, we've got some core things: P servers, we have HTML, and then we have hyperlinks. And that means that anybody can publish up their document and connect it to someone else's document, regardless whether that person is living next door or is on the other side of the world. I'm just describing the web as it is. Some of you use that over the last few years. Some incredibly clever people have worked really, really hard to use these servers and URLs and hyperlinks for data. So to give you an intuition on that, then currently if you click on a link, you get back the web equivalent of a Word document. And with the tech that these guys have created, you can click on a link and get back the web equivalent of a next, and where some links to another, then we use a hyperlink to connect them. So at the heart of this idea is the URL. Each data item gets its own unique URL, and then so just like each web page does on the web, data item, we use the URL of that data item to create a hyperlink. Now, this is data integration on the web scale, and most people don't know this. That's a third of all web pages now contain these little islands of data, and Google and Facebook are crawling the web and LD out of these. So that's in a third of all web pages. But wait a second, if web scale is built, why not take this exact same text and bring it in the enterprise firewall? It gives us everything that we need to create enterprise knowledge graphs. Let's segmentation level for a second. What would this look like? Well, first of all, above each application, you'd give it its own little data website. So P server, and it publishes its key data, the W3C standard RDF, which is nothing different than those three little statements that create our distributed graph. And they give each data item a unique URL. So then applications part of the and then they're connecting and linking together with each other resolvable URLs. This architecture is scaleless, like the web is scaleless. You can just keep on adding web servers and and that's exactly what you can do here. It is, and it's simply exposed out in this vast connected network. And it's decentralized, it's the application of data integration work. Just load all of the web into your web browser. User or an application doesn't need to have, or for that matter, doesn't even have the rights to access all enterprise. And at a kind of holistic level, we could view this as splitting the graph. We've got this vast, slow, distributed graph available by the data website publication. And then we've got a series of fast, compact graphs where the user is basically just getting the subgraph that they're at. By connecting the information, the web has made humanity more powerful, I think. And we can say that not everything about the web is good, but I think undeniably at a species level, by creating this rich network of connections, it's made humans faster, it's made us more efficient, and it's made us more adaptable to change. Now, when we look at the data integration problem and we look at the data that exists within our large enterprise, the problem can, of course, appear to be insurmountable. And for me to be coming on here and talking about connecting the near sum of an application of an enterprise's data whole can seem ridiculous and somewhat silly. But all I would say to you is shows that it is possible to connect information at scale. It gives us a model for success. So what do we have to do? Well, we take the standardized, battle-hardened tech stack that runs the web, and we apply it in the boundary of our enterprise firewall. The result of that would be a decentralized enterprise knowledge graph that is capable of integrating the near sum of all of your data together into a richly connected network. And then connecting your data will make your enterprise faster, more efficient. It'll make it more adaptable to change. In short, it'll make it more powerful and much better positioned for the oncoming AI army. And that's me finished there.
Good looking slides. Some people ask, how did you actually produce those slides?
They're handwritten. I guess it shows how obsessed that I've been with this subject, that I've lovingly hand drawn them.
I thought so, but I just figured I'd ask. Many people were actually curious. So another question that we got was whether you can actually recommend technical stack for implementing this vision that you outlined, and specifically using open source tools, something that you're familiar with, that you have worked with, and you can recommend.
Yeah. So one of the good things is there is a lot of open source here. So if you were looking to create your sort of data website and your data consumer, you could do a lot worse than look at the initiative that's currently being led by Tim Berners-Lee, which is the Solid initiative. So it's out on the web. They're thinking about it in terms of allowing data sharing for individuals out on the web, but it provides a pretty good model as a starter there. Then in pretty much every language that you can name, you will find HTTP servers, and you will also find libraries for working with RDF and manipulating that. Those libraries will include stores for querying the data, but you ultimately, if you kind of start pushing the boundaries of that and want to have a lot of information in one of these nodes, you will probably want to turn to a commercial, what they call triple store at that point, of which there is a vibrant market developing.
Yeah, I was going to say that yes, Solid is really a great initiative, even though at this point it's not really production ready. I mean, we have seen some use cases recently presented by commercial entities that are using it, but at this point it's more proof of concept than production ready.
Yeah, that's right.
Mm-hmm. Another question that we got is whether you can very, very quickly outline the difference between a relational database and graph in terms of the result of an application. So the question is that, you can query data using both, and you can, to the end user, it may look the same. I guess the answer would be that, it's not as easy to integrate data, and that's the whole point, but I'm curious.
Yeah. Once you execute a query, if you execute a query and it's coming back in tabular form, I mean, generally you get an option of either I'm going to execute a query and I'm going to bring back in tabular form, or I'm going to bring back basically select a subgraph. So if it comes back in a graph form, then that's a richer structure that you might do like graph visualizations over and that sort of thing. So that's kind of one difference. But at the table level, not particularly different. But I think you get the point there, that for me, it's the power of the graph database is that it's making connections, the relations between data items, first-class citizens. And when you marry that up with HTTP and a decentralized approach, it gives you the kind of power you need in order to connect your information together.
Mm-hmm. So one last question that we can take. Let me see. So what's the probability that the triples created by different applications actually communicate? So different expressions or different spelling? I think that's a tricky one.
It is, but I'd like to speak to it. So this is where like this kind of idea of creating an internal data market. So it's by no means the end of the job for the people in the centralized data and architecture teams. They've got a big job in front of them now. It's just kind of changed. So now we're talking about, okay, we're going to push this data integration problem out to the entire organization and let everybody get involved in it. So we're going to let users kind of start specifying the queries that they want, and we're going to let applications start publishing the data that they hold and start connecting to each other. But if they just publish out exactly what they've got, then all you're doing is publishing out a massive hairball that's just going to be as messy. It'll be connected, but it will be a disorganized mess. So you're not really you've again run away from the problem if you do that. So the job of the central architecture team becomes a very, very hard one, which is to kind of steward and shepherd this process. So they need to define like what's called an upper ontology, which is basically like the sort of model. And fundamentally, this is part of the mindset shift that we go, that an enterprise kind of goes about, stop thinking about its data in terms of the applications that are holding the data and put a kind of interface over the top of that, and that interface is the model, is the common upper enterprise ontology. So within these large enterprises, they might have 50 to 70 separate applications, some of those applications with even thousands of different tables in them. But when you kind of boil it down to the type system that's sitting in there, the actual entities that these things, that the kind of representing, like the trades or the people or the etc., you're probably not talking about more than sort of 500 or 600 concepts. So it's a massive, massive complexity reduction to abstract away the application layer and put in front of that this nice, clean, connected model. But that's the hard work. What the architecture that I have laid out here provides you the technical tools in order to do that work. So you've got the graph part, which allows you to do the connectivity. You've got the HTTP, and you've got the whole web stack, which gives you endless scalability. So those things aren't going to be a problem. You've got the tools there. But it doesn't do the job for you. There's not some machine learning algorithm yet that's going to come in and clean and connect up all of your data. No, that job lies in front of you, and hopefully the decentralization process with the correct incentives and the correct regulated market, and the regulation of the market is coming out of the central data team. So they are defining these models. They are creating working groups of interested people and getting applications to publish into these models and conform to this upper enterprise ontology. They got to kind of rate applications and give them star ratings for the quality of the data that they're doing, and encourage people to move towards. You basically have to create an ecosystem. How long that will take to do, that it's a big job, but it's a pathway forward from where we are now to where we need to be.
Okay, thank you. Yes, and indeed, ontology mapping and vocabulary mapping is one of the thorniest problems in this domain. So there's no way we could possibly address it now. I think we've already said enough, and we're already a bit over time as well. So we'll have to wrap up. Thanks again, and we'll try to address as many of the remaining questions. There's many of those offline. Thank you.
Thanks.
Bye-bye.